Good morning, mathematicians. Today we are going to be working on subtracting polynomials. Now, it's a lot like adding. We just have to take an extra step at the beginning. So something I want to remind you about, probably from middle school, was distributive property. Distributive property is when we have a number or a negative on the outside of a set of parentheses. This example, I would read this as 3 times the quantity of x plus 2. So I say the 3. Remember, there's actually multiplication going on here. It is 3 times the quantity of, that's what I say for parentheses, 3 times the quantity of x plus 2. In distributive property, what we do is we need to distribute that 3 to everything on the inside. It's kind of like bringing Takis to your class. You do share with your friends and you share with everybody. So I have 3 times x, and then I have 3 times 2. I do the operations and I end up with 3x plus 6. Now there's a couple ways you can do distributive property, so you can decide what works best for you. Now when we are working on subtracting polynomials, the first thing we do have to do is distribute that negative. This has to happen. If you don't do this step, you will get an incorrect answer. I will show you how to distribute the negative once we start the problem. Once we have distributed the negative, then you actually just follow the adding rules. The same adding rules that you worked on in the prior lesson. Okay, so here we go, subtracting polynomials. Notice here it does say subtract polynomials, and we do have the negative sign. Now what this means is I am taking away all of this. I am taking away a negative 4q to the 5th. Remember, when we take away a negative, we are actually adding. So for me, when I am distributing the negative, there's 2 ways to do it. I can either draw arrows and rewrite everything and do the multiplication, or I just flip all the second signs. So watch. It's not actually as hard as it sounds. There we go. I am now going to give this negative to every single term inside the parentheses. Now you don't have to draw all of these arrows. I'm just showing you what I'm doing. When I distribute that negatives, it turns each of these into their opposites. So 3q to the 4th becomes negative 3q to the 4th. Negative 4q to the 5th becomes positive 4q to the 5th. Negative 8q to the 2nd becomes positive 8q to the 2nd. Negative q to the 6th becomes positive q to the 6th. And distributing that negative all the way over to the positive 5qs becomes a negative 5q to the 3rd. Now that I've distributed, I actually treat this like an addition problem. So notice here I have a negative 3q4. Notice that I'm leaving my first one the same. This one isn't affected. Negative 8q to the 2nd and negative 2q to the 5th. So to answer this problem, I'm now just going to circle all of my like terms. So now we are adding polynomials. I switched my subtracting to an adding problem because adding is a lot simpler than subtracting. So let's go ahead and find our like terms. Notice I have a positive q to the 6th. There's only one q to the 6th. So I'm going to write that over here, q to the 6th. That one's done. Now, remember, we're going in order, so 6, I need to look for the 5s. Q to the 5th. There's a negative 2q to the 5th and a positive 4q to the 5th. So I'm going to bring these both together. Now, if you need to have your imaginary number line, notice I have a negative 2q. So I'm going to go negative, I'm going to go left, 1, 2. Then I have a positive 4, so that means I'm going to go 4 to the right, which lands me at a positive 2q to the 5th. Okay, those are done. Now I'm going to look for, I went 6, 5, now I'm going to look for my 4s. Exponent of 4, I've got a negative 3q to the 4th and a negative 3q to the 4th. Do I have any others? Nope. So I'm going to bring those two together. Now, since this is a negative and this one's a negative, they are the same. So I'm going to add them. I have a negative 6, and I just keep the q to the 4th. Those are done. Next, okay, 6, 5, 4, I need to look for 3's. Here's an exponent of 3. I only have 1, so I'm just going to bring it right down here. Negative 5q to the 3rd. And that one's done. And last one, I have a q to the 2nd. That's a negative 8q to the 2nd. Positive 8q to the 2nd. Oh, that's interesting. I have a negative 8 and a positive 8. That means I'm going to end up with a 0. So in our mind, this is what we're doing. It's plus 0. But as mathematicians, we don't need to do that. Now, I do notice that some of these are kind of long. I am actually going to have you, as you're watching the video, just do 1, 3, 5, and 7. If you get 1, 3, 5, and 7 correct, then you don't need to do the evens. So take your time and do them well.